Before we begin, make sure you watch until the very end, because what you're about to hear completely changes how you think about black holes and maybe even reality itself. Imagine this. Right now, somewhere in the universe, a black hole simply vanishes. No explosion, no warning, no dramatic flash of light, just gone. What happens next? Does everything nearby get flung into chaos? Does space itself tear apart? Or does nothing happen at all? At first, your instinct might be to think that everything around it would instantly fly outward, like releasing a stretched rubber band. After all, black holes are known for their extreme gravity, but here's where things get strange. The universe doesn't work the way most people expect. Let's say there's a star orbiting a black hole at a safe distance. That star is held in orbit by gravity, just like Earth orbits the Sun. Now, if the black hole suddenly disappears, you might think the star would immediately shoot off into space, but it wouldn't, at least not right away. That's because gravity doesn't act instantly. Changes in gravity travel at the speed of light. So, if the black hole were, say, 1,000,000 kilometers away, the star would keep orbiting as if nothing had changed for a brief moment. Only after that delay would the star realize the black hole is gone, and when it does, it wouldn't explode outward. It would simply continue moving in a straight line, following the direction it was already traveling. In other words, the star would drift off into space, no longer bound, but not violently thrown away either. It's less like a snap and more like letting go of a spinning ball on a string. Once released, it doesn't jerk outward, it just keeps going. Now let's scale this up. Imagine a supermassive black hole at the center of a galaxy. These monsters can have millions or even billions of times the mass of our Sun, anchoring entire galaxies together. If one of those suddenly disappeared, the effects would be profound, but still not immediate. Stars near the center would continue their orbits briefly, unaware of the change. Then, one by one, their paths would begin to unravel. Instead of orbiting the center, they would move outward along their current trajectories, slowly transforming the galaxy's structure. Over millions of years, the galaxy would begin to disperse, like a cosmic whirlpool losing its center. But here's where it gets even more fascinating. The disappearance of a black hole wouldn't just affect motion, it would affect time and space itself. Black holes are extreme distortions of space-time. They warp the fabric of reality so intensely that time slows down near them. If a black hole vanished, that distortion would also vanish, but again, not instantly everywhere. The change would ripple outward at the speed of light, like waves spreading across a pond. As that ripple passes, clocks would subtly change. Regions of space that were once stretched and warped would relax back into a more normal state. It's not something you'd notice directly, but on a cosmic scale, it would be a fundamental shift in how space behaves. Now here's a question that might be bothering you. Can a black hole even disappear? According to our current understanding of physics, yes, but not suddenly like flipping a switch. Black holes are thought to slowly evaporate over time through a process called Hawking radiation. This is an incredibly slow process. For a stellar mass black hole, it would take far longer than the current age of the universe to completely evaporate. As a black hole shrinks, it emits tiny amounts of energy. Over trillions upon trillions of years, it loses mass until eventually, in its final moments, it releases a burst of radiation and disappears. So in reality, black holes don't just vanish, they fade away. But for the sake of this scenario, we're imagining something more dramatic. A sudden disappearance. And that leads us into deeper, more speculative territory. Halfway through the video, if you're enjoying this kind of mind-bending exploration, make sure to like the video, subscribe to the channel, and turn on the notification bell so you don't miss what's coming next. What if the black hole didn't just evaporate, but instead transitioned into something else? Some theories suggest black holes could be gateways to other regions of spacetime, or even other universes. If a black hole disappeared, it might not be gone yet, might have transformed. In that case, the gravitational influence would still vanish from our universe, but whatever was inside might continue elsewhere. Everything that fell into the black hole, matter, energy, even information, could reappear in some form beyond our observable reality. This touches on one of the biggest mysteries in physics, the information paradox. If black holes can evaporate and disappear, what happens to the information about everything they consumed? Does it get destroyed? Does it escape? Or is it somehow preserved? Physicists are still trying to answer that question, and the answer could reshape our understanding of the universe. But let's bring it back to something more tangible. Imagine our own solar system, but replace the Sun with a black hole of the same mass. Surprisingly, Earth would continue orbiting just as it does now. The only difference would be the absence of light and heat, which would obviously be catastrophic for life. But gravitationally, nothing would change. Now imagine that black hole suddenly disappears. Earth would continue orbiting for about 8 minutes the time it takes light and gravitational changes to travel from the Sun to Earth. Then, suddenly, the gravitational pull would vanish, and Earth would move off in a straight line into space. No explosion, no dramatic tearing apart, just a silent drift into the darkness. Now let's go even deeper. Black holes don't just affect objects, they affect light itself. Light that passes near a black hole gets bent, creating gravitational lensing. If the black hole disappeared, that lensing effect would also vanish. Distant stars and galaxies that appeared distorted or magnified would suddenly snap back to their normal appearance, but again, only after the delay caused by the speed of light. It would be like watching the universe subtly rearrange itself. And then there's the question of what happens to anything that was falling into the black hole at the moment it disappeared. This is where things become truly bizarre. From an outside perspective, objects falling into a black hole appear to slow down as they approach the event horizon, never quite crossing it. But from the object's own perspective, it crosses the horizon and continues inward. So, if the black hole vanished while something was in that process, what would happen? Would the object be released? Would it be destroyed? Or would it be trapped in some kind of undefined state? We don't have a clear answer. Our current theories break down in these extreme conditions. This is where quantum mechanics and general relativity clash, and we don't yet have a unified theory to describe what really happens. Some possibilities suggest that the object could re-emerge as if the black hole had been holding it in suspension. Others suggest it would be converted into radiation, its information encoded in subtle quantum patterns. Whatever the answer is, it's almost certainly stranger than anything we can easily imagine. And here's one more twist. If black holes can disappear, even slowly, that means the universe has an expiration date for them. Given enough time, every black hole will evaporate. Eventually, the universe could become a vast, dark expanse filled mostly with low-energy radiation, a far cry from the dynamic cosmos we see today. This idea is sometimes referred to as the heat death of the universe, where all structure fades away and everything reaches a uniform, cold state. So the disappearance of a black hole isn't just an isolated event, it's part of a much larger story about the ultimate fate of everything. And yet, despite all of this, black holes remain one of the most mysterious objects we know. They challenge our understanding of physics, push the limits of our theories, and force us to ask questions that don't have easy answers. What really happens inside them? Where does the information go? And what would it truly mean for one to disappear? We're still searching for those answers. Before we wrap up, I want to hear your thoughts. What do you think would happen if a black hole suddenly vanished? Do you think it would be a quiet event or something far more dramatic? Let me know in the comments below. And if you made it this far, don't forget to like the video, subscribe, and turn on the notification bell so you never miss another deep dive into the universe's biggest mysteries.